Hi, welcome to What's New in Android Development Tools. I'm Jamal, a product manager on the Android DevTools team.
And I'm Tor, I'm the tech lead for Android Studio.
So we're excited to show you some of the new features that we've been working on inside of Android Studio. As you know, Android Studio is the official IDE for developing apps for Android. Before jumping in, I just want to spend a few moments highlighting some things you might have missed since we last spoke with you. So last year at I/O, we launched Android Studio 3.0, and that included things like a new performance profilers, Kotlin language support, adaptive icons, and a new Android emulator with Play Store integrated, plus 20 new features. Early this year, we launched Android Studio 3.1, and let's talk about it. So Android Studio 3.1 was focused on performance and quality. We fixed over 800 bugs and stability issues. 40% of our time was fixed on issues reported by you. So thank you for your patience and feedback. Now, we're certainly not done with quality. We've heard loud and clear from you that performance and quality is essential. So we're continuing to invest in that. But even with our focus on quality in Android Studio 3.1, a few bugs slipped past us. And so thank you for those who reported those issues to us to allow us to fix those issues. So in addition to quality, we know that build speed is also critical for you. So inside of Android Studio 3.1, we worked on that. So for example, when using D8 with Dsugar integrated, we drove upwards of 16% build speed improvements on full builds without caching. So that's a great improvement. So in addition to build speed and quality, in Android Studio 3.1, we looked on a few different new features, including SQL code editing support. So this has code completion and project navigation. So if you're using any of the Room database APIs or any of the SQLite APIs, this should be a plus for you. So last year, we announced Kotlin as a first-class language on the platform and inside of Android Studio. Since that point, we've been continuing to invest into Kotlin. So inside of Android Studio 3.1, you can not only do Kotlin checks in the IDE, but also on the command line. So if you do a lot of automation tests with Kotlin, now you have that support built in inside of Android Studio. Now, for those of you who have C or C++ code, here's also a treat for you. We added a C++ CPU profiler. And again, it allows you to drill into your C++ code and understand the performance impact of your C++ code. And of course, that's on the unified timeline inside of performance profilers. And speaking of performance profilers, we also updated the network profiler. So you know that many of you have multi-threaded network threads in your app. So now you can look at each individual thread and see the performance of that aspect. And of course, you can drill into the call stack and see down to your source code what's happening. And of course, with each version of Android Studio, we try to include the latest version of IntelliJ in there. So one of my favorite features in this version of IntelliJ is actually this new feature called the SVG Previewer. And what that's cool is that as I'm importing and managing my SVG assets and converting those to vector drawables, it's very convenient to be able to double-click back into the source asset to see the SVG file. So that comes along with the IntelliJ update. And of course, with Android Studio 3.1, we also worked on some updates to the Android emulator. One of the pain points we heard from you is that the emulator is too slow to boot up. So as you saw this morning from Steph's keynote, we enabled Quick Boot. And Quick Boot allows you to launch the emulator in under 3 seconds. So if you've had a chance to try that out, please do. All right, so that brings us to today, to talk about Android Studio 3.2. So our team works closely with the Android framework and the Google engineering teams to ensure that all the latest Android technologies and APIs are tightly integrated to accelerate your development flow. So for example, with Android Studio 3.2, you can test and validate and integrate all the latest Android APIs from the P Developer Preview. And as announced this afternoon, we have a brand new app format called the Android App Bundle. So with Android Studio 3.2, you can build this bundle, and in a course of time, you can deploy a customized APK to users using Google Play's dynamic delivery system. And lastly, Android Studio is a major component of Android Jetpack. And again, Android Jetpack is a set of libraries, developer tools, and a set of opinionated guidance to help you quickly and easily scale to make great apps for Android. Now, for Android Studio 3.2, we worked on a range of features across each development flow in your process. So instead of me talking about each individual feature, I'm going to actually have Tor give us a demo to tour all the cool features of things you can do inside of Android Studio 3.2. And I'll come back and talk with you afterwards. With that, Tor.
All right, so it's my pleasure to show you all the new features that we have built over the last year. So the first thing you'll notice is that we have this new window on the right. It's the What's New window. So in this window, we'll be showing it to you once per release. And we're sort of highlighting the important things for you to know, changes and new features in that release. And if you look at 3.2, the number one thing that we're profiling is the new Android App Bundle support. So let's get right into that. So the key takeaway about app bundles is that it lets you package and upload your app in such a way that the Play Store can create many different versions of your app, one for each combination of chip architecture, screen size, and even locale. And that makes the download smaller, right? So in Studio, all you have to do is rebuild your app. So if I go to our Generate Signed APK wizard, you can see there's a new option in it now for generating a app bundle. And here I can sign it. And it's really important to understand that for Google Play to do this, it has to sign your app. So you have to give it your encryption key to do that. So I'm going to choose to export the encryption key. And note also that it's not exporting it into the bundle. Okay? So if you look at the little notification here on the bottom right, there's a little link that we added so you can see where we stored that key so you can upload it. The UI needs a little work, so we'll tweak that. So now that we've created this bundle file, we can take a look at it. So the Apk Analyzer also works on bundle files, naturally. And if you look at this, it should look pretty familiar. So dynamic delivery is really, really easy for you to do. It's basically, upload your key and rebuild. And that's in production today. We also are previewing dynamic feature modules. And so if you look carefully at my bundle file, there's actually this other thing called Article Composer. That just happens to be a name I chose for a dynamic feature in this app that can compose articles. Right? So how did I do that? I went to the New Module menu. We have a dynamic feature module type. And here, it doesn't want to go.
Select.
Oh, OK. Here I basically get to choose the name of the feature and also enter target. I see that's the problem. I have network issues. I've already created this module, obviously, since you see it in my bundle file. So let me just show you how it's all wired together. So first, I have a new module where we apply this new special Gradle plugin for dynamic features. We have a manifest in that module where I can basically say that I want this to be on demand, and we want the Play Store to fuse it so that it can build APKs for older devices that don't support this. And in our main app module, we link to these dynamic features. So creating a dynamic feature module is a lot more work for you. You're going to have to use the PlayCore library to react to download and installation events. But it's really useful if you have some large functionality in your app that not every user is going to want. So you can have your base app be small and then do the on-demand installation of these other features. One other thing we've added to the run config dialog is the ability for you to choose which features are included when you are testing locally. Now, to test the download and installation stuff, you'll need to use the Play Console testing track. All right, so that's dynamic apps. Let's take a look at the profiler. So we have several new features in the profiler. I'm going to open it up. And I have an app running. This is the Plaid app. So the first thing you'll notice in the bottom left here is we have a sessions view. So you can record multiple profiling sessions, and then you can go in and sort of compare results. One thing I've already recorded earlier is a new feature we've added, which is Systrace. So Systrace is this really powerful profiler. It looks at data from the kernel, so I can see what's going on different CPUs. There's thousands of tracing events from the kernel that's being recorded. It's probably hard to see on the screen. There's some faint graduation of colors here to show you all these events. So that's a CPU tracer. I'm sorry, that's Systrace. Let's go back into our CPU view. Now, let's assume, actually, let me start. These were all pre-recorded sessions. Let me now attach to the current running session. So here's our telemetry view. So now I'm going to go into the CPU profiler. And let's say I'm interested in recording why my UI is so slow when I click on this thumbnail on the right. Until now, what I would do is click on this Record Method Trace button on the left, and I would try to quickly press it after doing the action. But what I can do now is actually trigger it from code. So in 3.2, we have this ability for you to call the debug method. This is a standard SDK method, ender.os.debug. So I'm telling it I want to start method tracing here at the beginning of onCreate. At the end, I'm going to say stop method tracing. Right? So now that I'm going to click on the UI, take a look at what happens in the CPU view. So you can see it captured exactly the range of code that I'm interested in, and I can now drill in and figure out what's wrong with my layout inflation. So that's the CPU profiler. Let's move on to the network profiler. So let me scroll out a bit. So as Jamal mentioned, we have two new features here. We have a threads view, so you can see which thread is doing what. Some random picture from this app. We are also showing requests and responses for the network profiler. In the memory profiler, our biggest new feature is the ability to show you JNI references and the allocation trace from the JNI references. And last but not least is our new energy profiler. Let me zoom out a bit. So the energy profiler helps me figure out what's going on with my battery life. So if I take a look earlier in the app here, you can see we have this legend on top. And this is showing me that I have fairly light CPU usage, but it's telling me if I'm touching the network, if I'm getting location requests, if I'm running alarms, and if I have wake locks. And if you see there's this big red bar on the bottom, that's showing there's a wake lock in effect. A wake lock means that the device cannot go to sleep. This is obviously really bad for battery life, right? So let's look at this range. And here it actually shows me the real wake lock names. We can see our first wake lock was alive for about 4 seconds. That's normal. But the second wake lock, still unreleased and going for 50 seconds. That's not good. So what I can do is click on that wake lock, and we drill down to where the wake lock was acquired. You can see, obviously, this is a bug I added. This is not the Plaid app's fault. This is just to show the wake lock. So the wake lock detector and the whole energy profiler is new in 3.2 and hopefully very useful to you. All right, so that's it for the profiler. Let's talk about the emulator a bit. So let me stop profiling. All right, so here we are in the emulator. We have the new snapshots that you saw earlier, and we actually have a whole UI for this. So I can see here that my quick boot obviously looks like the lock screen, right? But I've also recorded a session in the middle of searching at Google Maps, so I can just click the snapshot, press play, and my emulator's instantly in that exact state. I also recorded a snapshot while running the clock. So again, if I press play, you can see it's instantly in that state, 15 seconds into recording the snapshot. And recording a snapshot is as simple as clicking the take snapshot while you're running your emulator, and then you can bring it back. You can see there's also a special quick boot snapshot, right? That's the one that the emulator is going to come back into when you restart it. So if I exit the emulator right now and bring it back up, you should see that, yes, it comes back really quickly. We've added a few other features to the emulator. So by popular demand, screen recording. A lot of you wanted this. This lets you record a video of what's happening along with audio. And we've also enhanced the camera. So let me start the camera. Yes. Yes. All right. So what we've done here is we are now feeding the camera and the emulator sensors, the fiction that you're in this 3D world here. So actually, I have to hold Alt key. So I can move around in this 3D scene, and this is really, really important when you're building AR apps. And speaking of AR, we have some support back in the IDE for that. So let's see. This is a GLTF file. And we have a plugin. Let me see, settings. We have this scene form plugin. So you heard about scene form in the keynote. a sceneform plugin which helps you preview your 3D models. So here's this GLTF file. I can go in and import this as a sceneform asset. We support GLTF files, we support OBJ files, we support FBX files. And so when I run this import, it's going to create a Gradle task for me, which is creating these SFA, SFB files that is core to sceneform. And then I can open my SFA file. And the important part here is that we have a viewer. Ta-da! So now I can explore what's going on in a 3D sense, what this model is doing. All right, so that's sceneform. Let's switch gears a bit and talk about Jetpack. So if you look at the package names in the editor here, you can see that we have Android.support, we have some v4, some v7. These are super misleading version numbers, right? And so we decided we needed to clean up our legacy a bit. And so we are repackaging everything from Android support over to Android X. And to help with that migration, we're providing all of our libraries in both the old namespace and the new namespace for now, as well as an automated refactoring tool. So let me show you how that works. And by the way, this also applies to XML files, where you have these class names, and even Gradle files, because we are also repackaging the group IDs and artifact IDs for these libraries. So I go to refactor, refactor Android X. It's going to look through the code. Then it's going to offer to preview the changes. I'm feeling lucky. So you can see here, actually, let me open up the Git view. And I highly, highly, highly recommend that you all make backups and use version control, both preferably, before you do this. So you can see that we've actually replaced a bunch of the code here. And it should work. But we are aware of some bugs already in Canary 14 and in Canary 15. So we would really like you to try this and give us feedback on what's broken so that we can make this working smoothly for everyone before 3.2 goes to stable. All right. So Jetpack is about a lot more than cleaning up legacy code. We are adding a number of new libraries. And one of the most important ones for the tools anyway is the navigation library. So the new navigation library does require you to architect your app for the navigation library from the beginning. So this is not magically machine-learned intelligence figuring out what your app's doing, OK? This is a navigation graph we have created for this app. So let me show you how the navigation library works, the plumbing underneath it first. So I have a launcher activity. I point that launcher activity to a sort of root layout, and in that layout, all I do is I put a navigation host fragment. And this navigation host fragment will do the dynamic dispatching at runtime. And then we point the nav host fragment to this navigation resource file. That's a new resource type that we've added for this specific library. So now we're looking back at the navigation resource file. It's just an XML file, but we have a nice visualizer for it. So let me actually go ahead and run the app. So if you look carefully, you can see that near my the mouse pointer, there's a little home icon. That tells me that this page is the start destination in the app. I can just go to the title screen instead and click on Set Start Destination. And when I run again, you'll see that now the app instead starts on the title screen. I didn't change the launcher activity or anything else. All I changed was the navigation graph. So that tells the nav fragment where to begin. All right, so next, I'm going to click the play button, and it does nothing. Why is that? Well, the play button is just a button in this layout, right? So if you look at this layout, there are two arrows coming out of it, right? The first one on top here has the action play. That's one of the things we want to navigate. When the action play happens, we want it to go to this page. When the action leaderboard happens, we want it to go over here. So let's go take a look at the code. So I'm going to drill into the layout by just double-clicking. So here's our button. And I'm going to jump to the on-click handler for that button. It's called onPlay. And I'm going to uncomment this code. So what we're doing here is we're finding the nav controller. That's from the navigation library. And this is Kotlin, so we have an extension method right there on the view. But in Java, you could just call the navigation helper. So we get the nav controller, and we say navigate to the action play. All right, so now I'm going to deploy that to the app. And once that gets there, I can now press play, and you can see it goes where we want. So I can now go back into the navigation screen, and instead of jumping, when I press play, instead of jumping to the register thing, I'm going to have it jump over to our in-game screen instead. So I'll just make that change. Notice the code doesn't change. The code just says take the play action. All right? So now, when I press play, instead we go right into the game. Right? So the routing table is here. Another thing we can do is to select this transition and say, you know what, I like an animation on this transition. So I'm going to choose the rotate cross to tick animation. And again, I'm going to deploy that to the device. And when I press play now, look at the screen. You can see it rotates, right? So there's a lot of features in the nav editor that I'm not getting into, for example, passing arguments in a safe way from one screen to another, or nesting graphs. I'll just show one last thing. Deep links. So I'm going to press the plus button here to create a deep link. And let's pretend for a moment that I own the google.com domain. So if I look at the manifest file here, all I've done in the manifest is register my activity with the launcher intent. And also, I reference the nav graph. But now let's take a look at the merged manifest. Right? This is what we compute on the fly when you build, and we also compute it in the IDE, obviously. If you look at the bottom here, we create intent filters for you that are handling this deep link. Right? So you just put the deep link in your nav file, and now your app will respond to deep links. So that's the nav editor, which is new in 3.2. Let's talk about the layout editor for a bit. So as you can see, you get this nice graphical view of the app. Well, the reason that works is that we have a highly visual app here, right? So you can sort of see from the outline what it looks like. Sometimes you're not that lucky, but what really helps is you can add sample data to your app. We've had the plumbing for sample data for quite a while, but in this release, we made it a lot easier to use. So first of all, I can go over in the property sheet, and you can see next to the text property, we have this design time property. I'm going to bring up the customizer. And here, I can explore all the different sample data types we have. For this one, I'm going to choose a full name. I can also select a widget in the design surface. And if you look carefully, whenever you select something, there are 4 buttons under it. Right? The 4th icon is a wrench. That means design time attributes. Right? So I can click on that, and I can also set design time attributes from here. And the reason it's important to know about that trick is that it's particularly useful with lists. So let me open up a blank layout and drag in a recycler view. And that looks really unimpressive, right? This is what you get with the recycler view. But now, notice that below the recycler view, we have our wrench again. So I'm going to press it. This is our design time helper. And for list views and recycler views, we offer to customize the item list layouts for you. So if I press next, I can cycle through various list item layouts here. So we create one that looks sort of email list-like, one-liners, two-liners, three-liners. We even have a grid. So the design time helpers should help you make your layouts look better from the nav editor at least. The last thing I'll mention on the layout editor is that we also have some support for material theming. So here's a pretend compose window in an email app. So we have the new chip widgets. We have the bottom nav layout you can see with the sort of rounded curve. And everything I've shown you so far is in Android Studio 3.2. Now I'm going to give you a sneak preview of a feature for an upcoming release. Might not even be 3.3. So I'm going to open up a new layout for that. And the problem we're trying to solve is making animation easier. So what I have here is a subclass, I think, of constraint layout. It's sort of next generation constraint layout, which lets you do motion. So I can select my widget, and it has 2 constraint sets. So in the beginning, it's attached to bottom left. At the end, it's attached bottom right, top right. So I can play, and you can see we can animate between these 2 constraint sets. Let me actually go and turn on motion paths so we can see what's going on. So now we can see where this thing is going to go. Now, the important part is I can go in and add keyframes. So I'll add a Cartesian position keyframe, and I will, we can drag it over here, for example. And I'll add one more keyframe to rotate. So we'll set a random attribute. Actually, I want to do it somewhere else so that it's more obvious. So I'll add a new keyframe, over here. So let's see, new attribute. And I have to select it. And then we will say rotation should be, 45 is a good default. So you can see now, when I'm dragging through, you can see we both rotate and shift the X and Y coordinates. And the real power here is when we start combining these, right? So here is a more complicated animation demo. You can see here, let me make the timeline a bit bigger. Here we have a number of things happening. So at the beginning, we have a number of widgets. At the end, you can see we moved the motion layout, we've faded out the Google Cast icon, and we made the header smaller. So you can see as I'm pulling through, we get pretty fancy effects. And this library also lets you respond to touch events, which makes it a lot easier to use. So that's motion layout. No promises on when it'll be done, but we're very excited about this and working hard on it. So now, thank you. So now if we can switch to the other demo machine for a second. All right, so what you're looking at here is a Pixel Chromebook. And the really exciting part for us is that if I click on this button down here, you can see we have Android Studio running on it. Yeah. So we have, we have layout editor, we have Kotlin code, building works, a lot of stuff works, but there's a couple of things that don't work. So there's no ADB yet, so you can't run, deploy, debug. Some of you don't need to debug. You can upload straight to the Play Store and hope for the best. Yeah. Anyway, so I think at this point you still need to sort of tinker and be very comfortable with Linux, but it's a very exciting development, I think. So, I look forward to that getting done. And with that, I'm going to turn it back to Jamal to.
Yeah. So that's exciting. Good work, right? Exciting stuff. All right. So Tor touched upon all the visual changes we're making to Android Studio. I just want to spend a little bit of time talking about some changes to the build system that you might want to be aware of inside of Android Studio 3.2. Now, the biggest change we've made is supporting the Android app bundle, which you heard about earlier this afternoon. Now, as you saw in Tor's demo, we have a new little drop-down menu in the IDE where you can create a bundle and sign a bundle. Now, if you want a little bit more control, we actually added some additional flags inside your build.gradle file. And so in this example you have on the screen here, I have slides, perhaps? Slides? Slides, great. All right. So this example here, so I have a new bundle section in your build.gradle file. And so for instance, I have a split on density, screen density, ABI, and language. So these are just a few flags that you can configure to have some control what's actually inside your bundle. All right, so next is Android X Refactoring. So Tor gave you an example of how it works inside the IDE. And again, what happens from the build system perspective is that we will convert your legacy Maven dependencies and convert those to the new Android X namespace. We'll cache those and use those for subsequent builds. Now again, if you want a little bit more control what happens to your Gradle properties, we have a few things we added to your Gradle properties file. And so in this example, I have the enable.enable Jetpack set to true. And this is actually the default behavior. Again, what that does is it takes your legacy Maven artifacts and converts those to the new Android X namespace and caches those for new builds. Now let's say you have a brand new project, or perhaps you say, hey, look, I have all my dependencies already converted to Android X. I don't need this step. So in that case, you can actually change this flag to false, and we can skip this step. And what that would do is actually enable you to have faster build speeds when working with Android X. All right, lastly, D8 and R8. So D8 is our new default dexter inside of Android Studio. We actually launched D8 last year in Android Studio 3.0. We've been iterating on that, and now it's the default, and it's the replacement for dex. R8 is new. It is a new optimizer and shrinker inside the build tools chain, and it's our long-term strategy to replace ProGuard with R8. So that might be exciting for some folks. So again, to try it out, all you have to do is go to your your Gradle Properties file and go to enable R8 set to true. Again, this is experimental, so we do not recommend you actually publish your app to the Play Store just yet. However, please give us your feedback and let us know how it's working for you, and we'll let you know when it becomes stable inside of Android Studio. All right, so that was just a few things to talk about in the Android build system. If you want an even more in-depth session, we have a whole session for tomorrow called What's New with the Android Build System, presented by Jerome and Zav. I would also check out Best Practices when using compilers in Android Studio, presented by Jeffrey. And we have a few more classes as well on Android Studio. We have one more called Improve App Performance with Android Studio Profilers, presented by Esteban. That's also this week. And lastly, we have a class on What's New with Constraint Layout and the Android Studio Design Tools, presented by Nicholas and the Android Studio Engineering Design Tools team. All right, so before we conclude, I want to talk about one last topic. It's about feedback for Android Studio. As many of you know, we release Android Studio on a series of release channels, ranging from Canary, Beta, and Stable. Now, Canary is our bleeding edge release channel, where we have most of the new work, but a little bit of testing before it goes out to you. And on the other end, we have Stable, which receives the most amount of feedback and testing on our end before it goes out to you. Now, you may say, hey, look, I can't rely on Canary. I need to have my production code on Stable. If you didn't know, you can actually run Canary and Stable at the same time on your app project. Now, I want to highlight one important detail. It's about feedback. So the thing is, the earlier we receive feedback on a Canary channel, the higher chance it is actually for us to fix it. So the thing is, once we reach Stable with Android Studio, it's almost too late for us to fix things, and we're only going to fix very, very critical issues. Even honestly, if you wait until the very end of the betas, that's almost too late as well. So we really encourage you to download Android Studio on the Canary channel and give us feedback sooner than later. All right, to recap, Android Studio has a range of cool features across multiple flows of your development flow, from onboarding with Android Jetpack, building your first Android app bundle, testing Emulator snapshots, and understanding the battery impact of your app with a new energy profiler. In our course today, we give you a sneak peek of the new motion editor and some cool tools around AR development, and also some cool demos of Chrome OS support for Android Studio. We hope you enjoy this version of Android Studio as much as we do. All right, we want a little bit of feedback on this session, so please go to google.com/ioschedule to give us some feedback. All right, that's it. Again, I'm Jamal, and this is Tor. Thank you for attending our session on What's New in Android Studio.